Okay, as quickly as possible, what this first statement says is that when you have an x squared and it's equal to some number and you're trying to solve for x, what you're going to do is you're going to square root both sides, and that will get rid of the squared right there. What you need to remember, though, is you need to remember to do the positive and the negative. We call it plus or minus the square root, because, for example, if I said that x squared was equal to 16, there are two numbers that when you square that, you get 16. So when you square root both sides, you do plus or minus the square root, because the two numbers that you squared to get 16 are positive 4 and negative 4. So we would write that as plus and minus 4. Okay, so that's all that this first slide says, is just square root to solve and do the positive square root and the negative. So when you have a quadratic, not all quadratics can be solved using square roots, but when you do, you get that quadratic term or the squared expression by itself, and then you take the square root of both sides, remembering to do that plus or minus in front of that square root. And then if there's any other steps that you need to take, you would simplify that radical and do any other rearranging that you might need to do, because there could be stuff inside the quadratic term. So I'm sure that we're going to see an example of that here in just a second. So if I look here and I want to solve this quadratic using square roots, the first thing I would do is I would subtract the 7 to move it over, so that would give me a 6 on the other side. And then I would square root both sides. So I'm going to square root this side to get rid of the quadratic. And when I square root this side, I need to remember to do plus or minus. So at that point, what I have is on the left side, it got rid of the squared, so I just have the b minus 3 now. And on the right side, I have that plus or minus the square root of 6. If that square root could be simplified, I would need to do it. The square root of 6 can't be simplified, so I leave it the way it is. And so that means that my last step is just to add the 3 to move it over. So that becomes a positive 3, and then plus or minus the square root of 6. Now, I could have written this as plus or minus the square root of 6, and then plus 3. Both of them are correct. It's just a preference as to which way you want it arranged. I like it arranged this way for the same reason that I put my eyes in front of radicals. I want to make sure that that plus 3 right back here doesn't look like it's inside the square root. So we usually just put it in front, but you don't have to. I mean, you could write it this way, that's just fine. Okay, so this one, we're going to go ahead and, first of all, the left side already has the squared term, or the squared portion of it, isolated. And so we're going to go ahead and square root. And then this one is a different type of example, because we're going to square root that fraction on the right side. So I square root this side to get rid of the squared. And I square root this side, and I remember to do plus or minus that square root. So the left side, the squared is gone. All I have is the x plus 2. And the right side, I have plus or minus the square root of 27 over 64. So before I move the 2 over, I am going to go ahead and I'm going to take the square root of that fraction. So I have plus or minus. Square rooting that fraction means I'm going to square root the top, and I'm going to square root the bottom. And the square root of this denominator, of this right here, has a perfect square root. So I can just write it as 8, because that's the square root of 64. Now I do still need to simplify this square root of 27. Remember that that's the same thing as the square root of 9 times the square root of 3. So at that point, what I have is x plus 2 is equal to, plus or minus, the square root of 9 is 3. And then, of course, that other 3 had to stay inside the radical. And then that square root of 64 had already become an 8. And now I can go ahead and I can subtract the 2 to move it over. And so x is going to be negative 2 plus or minus 3 square root of 3 over 8. And remember that you could have put that -2 back behind. That's just fine. Like I said, this is just a preference of mine. Okay, so then the last example we're going to try is going to involve your complex number solutions. So I subtract the 9 to move it over. So I have a plus 2 squared is equal to -4. And so what that means is that when I square root both sides, so I square root the left to get rid of the squared with my a plus 2, and when I square root this side, and don't forget the plus or minus, I'm going to get an imaginary answer. Okay, so I have my plus or minus, the square root of 4 is 2, and the fact that there was a negative inside that square root makes it imaginary. And so then my last step is to subtract the 2. So I get -2 plus or minus 2i. So there's my complex solutions. Okay. Now, one thing that I think is kind of a cool fact, which will come into play later, but I want you to notice that if I wrote those as two separate solutions, I have my -2 plus 2i, or I have my -2 minus 2i. They're conjugates of each other. And there's a reason for that, but we'll get into that reason in a future unit. I just think that it's nifty to point out. So anyway, nice short notes, less than 7 minutes, and then you guys will have time to work and get help in class this week. Thanks. See you later.